Hello and welcome to another video. This video we're going to be doing a rare video of a daily problem. I thought this one was pretty interesting. So we're going to be doing shortest common supersequence. So in this one, you have two strings and you want to return the shortest string that has both string 1 and string 2 as a subsequence. If there's multiple, return any. String is a subsequence if deleting some number of characters results in the string. So they have this first example of CAB AC, and so ABAC is a subsequence, and so is CAB. And the second example, they have a bunch of A's and a bunch of A's, so it's just going to be the bigger bunch of A's. So that one's kind of obvious, right? Like if one string is a subsequence of another, then the answer is just that bigger one. So like if we have like ABC, ABC, and the other one's just like ABC, then the bigger one will be that one. This is going to be the answer. But let's say they have different characters, or like whatever. Like let's just say one string is like this, one string is like this. Like how do we make something here? So basically, yeah, I think there's like easier problems. That's like first of all, how do we know if a string is a substring of another string? Like let's say we have this string. Like how do we know that a string that's like ADF is a substring of that? So basically, in order for a string to be a substring, each of these characters have to appear in here, and they have to appear in the same order. So there has to be an A before D before an F. And you can kind of greedily just take that. So we can essentially just say like, okay, we're here and here, these match. So let's move this up. Now we need to have a D. We have a D here, and then like this. So basically like that. Yeah. So if we have two of these, then we need to essentially go through the characters of the first string and the second string and kind of figure out like what do we want to put in our result. So let's kind of walk through like some sample thing there, I guess. Yeah, okay. So say we have a pointer here. Let's actually just get rid of that. Pointer here. And when we're building like our total like result here, the first character is going to be one of these two, because like what else would it be, right? Like we don't want to just pick something random. Does it make sense? It's always going to be one of these two. So if we're iterating through these strings and the characters don't match, we have a choice: either take the first character or the second character. And then, so that's one case we can have, right? If they don't match, we're going to take the first character or the second character. Let's say we take like the F. And one of these is going to give you something better, or it's going to be a tie. We don't really know. So if we take the F, then now we have a choice between these two. So once again, we pick one. Let's say we take like the A or something. And then we're here. Now let's say we start taking characters from here. So let's say we take the next three characters from this guy. So we're over here. So if the characters are exactly the same, then you're always just going to take that one. And then move on. And then from here, let's say the characters we take is like DFO or something. So this is guaranteed to give you, like, those two will be a substring of this guy, right? Because we went through these characters in order and we put those characters into the result. So like this FASDF, there's an F, an A, an S, a D, and an F. And here there's a T, a U, an I, an S, and an O. So if we just go through the strings and just take the characters in order, if they don't differ, we just pick one and we keep going, and we get some kind of substring. That substring is going to be guaranteed to be, or that result was going to guarantee to have these as a substring. But the question is, like, how do we pick the best one? So like I said, I guess we can write down the cases here. So we have three cases. If characters match, just take that one and move both pointers up, right? If characters don't match, pick one and move one pointer up. And so the third case that I didn't talk about is if we're out of bounds on one of them, like let's say we don't have anything left here and we have something here. So if we're out of bounds, we'll just always take the other one. So if out of bounds on one, always just take the other. And so this is basically, if you notice, this is basically a DP problem. So if we were just asked, like, what's the longest substring, or the shortest substring that contains, or shortest string that contains both of these as a substring, this is literally just DP, right? So 1 and 2 is the recursive case, and 3 is the base case. When we're out of bounds, take the other one, and if we're out of bounds on both, then we're done. And by taking the character, we just have to do like 1 plus DP of the rest of it. So hopefully that makes sense how we can get a DP problem given 2 strings, return the length of the shortest substring. But we're not asked for the length, we're asked for the actual substring. So that's kind of the tricky thing. So in this thing, we're going to need to keep track of I and j. And I and j is like 1,000 here, so this is already n by m, or m by n, or whatever you want to call it. And we can't store an entire string for all of these, because that's going to be like n by m by another string, so that's going to be like max m, or it's going to be like m plus n or something, which will be too big. And also, we like to build on these strings, we'd have to like concatenate strings, which also wouldn't work. And we can't store it as an array of characters either, because even if we don't concatenate, this is still too big. So what we actually have to do is we can make this DP function that will just tell us like what's what's the result of this. Given I and j, what's the shortest string? And then we can just actually manually go through both of these and do those cases and then build up a result. So what's that going to look like? Well, let's take a look. So we're going to have this result, and we're going to have this DP function that we're going to make. And when we call it, we're going to get some result. So we're going to have a result. So like I said, if the characters are different, we're going to call dpij. Actually, sorry, we're not going to call dpij. We're actually going to call, so if this is I and this is j, just write it over here. We're going to actually call dp I plus 1j. This means we took this character, and now this is I plus 1. And here, this is dp I j plus 1. So we're actually going to call both of these, and then whichever one's smaller is going to tell us what character we take. So let's say this is smaller. That means the substring, if we take this character, will be smaller than this. So let's just say that that's the case. So we'll take the f. And then we're going to do the same thing here. We're going to call dpi plus 1j and update ij. So here I is 1, j is 0. We're going to call it again. And then let's say a is smaller. And now let's say, so here I is, you can write this down too. So now I is 2. And j is 0 in this case. So we're going to call it again. Now let's say this one happens to be smaller. So we're going to take the t. Now move this up. Now j is 1. Then we're going to call it again. Let's say this one happens to be smaller. So we're going to take the u. Now let's call it again. And let's say this one happens to be smaller again. So we're going to take the I. And now, if the characters are the same, then we can just take whatever one, because it doesn't matter. Like from our DP case, it doesn't matter. The DP will be the same. So now we'll just say, okay, we'll take the S, and we'll move both of them up. And then let's say j is smaller, so we'll take the j. I'm not going to keep updating these. So let's say we take the j here. And then we're out of bounds. And once we're out of bounds on one, we don't have to keep calling it. We can just always take the other one, and then we're done. And then we just join it up. And now we basically, so what we did here is our DP function gets called maximum n plus m times. It runs an O of 1 other than the, because it's recursive. And then we can build the string efficiently. And then we have a n by m time and n by m space solution now. So yeah, so we're going to build this DP separately and then build out this string. And there are some problems like this where you can't store the entire result in the DP function because it's too big. So this is what we're going to do. So I thought that was kind of interesting, but yeah, let's code that Python. Alright, so first things first, we'll make these. I guess we can make these shorter. So we'll say like mn, yeah, so like mn length s1, length s2. All right, so we're gonna have our dp function. So it's gonna take I and j, and so the base case is if we're out of bounds. So if I equals length of, or if I equals m, then I is out of bounds. So then we can just return however many characters we have left in the second string, which is just n minus j. So for example, if the second string is like 5 characters and we're on index 2, we have 2, 3, 4 left. So yeah. Okay. Same for the other one. Alright, so these are the 2 out of bounds. Now we have to handle the same character. So if s1i equals s2j, return. So we're gonna take one character. The string is gonna be one character plus dp of moving them both up. And if they're not, then we're gonna pick one or the other and return the smaller one. So return, we're gonna take one character from one of them plus the minimum of dp I plus 1 j, or dp I j plus 1. Okay. So this will tell us, given 2 indices, like what's the length of the shortest substring. Now we actually have to build the result. So and then we'll make ij 0 and 0. So while I is less than m or j is less than n. So let's handle the out of bounds cases first. So if I equals m, then we're just gonna take the j character because that's the only one we can take. That's 2j. And increment j. So if j equals n, then the same thing for the other one. s1i, increment I. All right. So these are the 2 out of bounds cases. Now we'll check for the same. So s1i equals s2j. s1i, we can pick one of them, they're the same. Alright, now we have the last case, which is the characters are different and we have to find which one is smaller. So elif dp of, so let's just say we take the character from the first string, so that would be dp of I plus 1j is less than dp of ij plus 1. That means it's better to take the character from S1. So if this is the case, we'll take the character from S1. Otherwise, we're going to take the character from S2. And yeah, you can clean this up a bit as well if you wanted to. I have like a billion else statements, but they're kind of short, so it's not that bad. Okay, j. All right. And then all we got to do is just return the join on the result. So yeah, I do think it's a little bit tricky. The DP, if they're just asked you like what's the length, it wouldn't be that bad, but because you have to build it as well, this is kind of how it works. And at least that's what I came up with. And yeah, usually using top down because it's easier. So maybe you can do bottom up. I don't think you can save space. I don't know. It's already hard enough, I guess. So, yeah. Top down, I feel like it's just a lot more intuitive. So, all right. Yeah, I mean, definitely bottom up will run faster because it's like arrays instead of like dictionary and all that, but whatever. So yeah, so as far as runtime and all that, so this DP function is m by n, and then we just have like in the function it runs in O of 1, and then the states is m by n. So this is m by n time m by n space. Building the string, these functions will run in O of 1 because they're cached. So what will happen is this is going to run in n plus m, and then the result is going to be n plus m as well. So the DP function is going to be the majority. So it's m by n and space m by n. Curious what this thing says before I guess it'll look at mine. So let's see if I get rid of it. M by n. Okay. All right. So yeah, hopefully this is helpful. It's kind of an interesting problem, so I want to go over it. Let me know what you think. And yeah, probably going to go back to doing more system design after this. So yeah, thanks for watching.